Hello, Casey. Thank you very much for joining me on my new podcast. And of course, you should introduce yourself a little bit. You can talk about the journey, about your experience in the chaos space. I know most of the people should already know you as the chaos guy. And also, what I'm trying to do to achieve with my podcast is to talk to experts from the space. I was already able to talk to Adrian Hornsby. We explored why it's often hard to get started with chaos engineering. In the last episode, I was able to talk to Russ Miles, and then we talked more about the cultural aspects, what a company needs to provide to be really successful in the chaos and reliability space. And now I'm happy to welcome you, and maybe you can say something about yourself.
Awesome. Yes, thank you. It's a pleasure to be here. It's an honor to be invited. So I have maybe 3 decades in high availability systems. That makes me sound really old, but I suppose I am at this point. At some point, so about 10-ish years ago, I was hired to Netflix. I had the equivalent of like an availability czar role there. And one of the things that fell under my purview was a charter for a chaos engineering team. At the time, chaos engineering was a buzzword in a series of blog posts from years earlier at Netflix. Not a lot was being done with that outside of a program called Chaos Monkey that was running. And so it was up to us to figure out what chaos engineering was and how to build a team around it and establish our own success criteria and all of that. So I went around the company and then around some other industries in Silicon Valley and asked, so what's chaos engineering? And the answer I usually got was, oh, that's when we break stuff in production.
Yeah.
And as cool as that sounds, that's a horrible thing to do in practice for no purpose. So instead, we sat down, metaphorically locked ourselves in a room for a month and looked at resilience engineering in particular, borrowed a lot from existing research into critical systems and high availability and reliability in systems outside of software, like nuclear power plants, air traffic control, shipping, railroads, things like that, military operations, and found that there was a ton of research outside of software that just hadn't been recognized or brought into software.
Yeah.
So we borrowed heavily from that material from Sidney Dekker in particular. Lauren Hochstein was on the team, so he had a lot of input into the development of the definition of chaos engineering, which we put up at principlesofchaos.org. The definition still up there, translated into a dozen or so languages now. And so that became chaos engineering. Then I went on to build and manage that team at Netflix for 3 years. We built some of the most sophisticated chaos engineering tooling that's out there right now.
Are you referring to CHAP, Chaos Automation Platform? Yeah.
Yep.
Nice.
And there are a couple companies that have similar things. I would say Netflix's implementation is still the gold standard. There's maybe this many companies that come close. But again, Netflix's implementation is fairly unique. Well, they're all very bespoke. From there, to meet hiring goals at Netflix, we started evangelizing it across the industry. Gartner tells me that 80% of the major banks in the US now have dedicated chaos engineering teams, which is good. So adoption is still increasing. I started conferences for chaos engineering. I wrote the book for it. So that's how I came to be the chaos engineering guy.
Nice. And before we zoom in a little bit in let's say like your key learnings from Netflix, I want to highlight a personal experience, because as I was getting started with chaos engineering don't talk about your age. No. I, I guess it was around 9 years ago, and around 7 years ago, I released the Chaos Monkey for Spring Boot applications on GitHub, and that was like for me a special moment. Beside all the buzz, there was one message on Twitter, and it was a message from you where you told me, "Hey, you're on a good track," and that was like a very special moment for me, because at that point in time, I was just an engineer sitting in Germany, was releasing something on GitHub, and then wow, there's something more. And so this was a very special moment for me. But now let's zoom in let's say your key learnings from Netflix out of chaos engineering. What was, or maybe you can share some aha moments from yourself.
Yeah, sure. I mean, so the empty space between what is currently considered industry norms and what we now know can be done is huge. So if you look at industry norm practices, right? Like so banks in particular have a high uptake of chaos engineering. So maybe putting them aside and looking at just industries as a whole. And I'll some of this is corroborated in the EU, but I'll just speak from a US based perspective. Yeah. The majority of companies, and everybody's a software company at this point, best practices or normal practices are around reliability and uptime and availability are either provably misleading, which is unfortunate, or reactive. So if you think about all of the fields in incident management or around reliability, they're all about waiting for something bad to happen, an incident, and then how do we deal with that, or how do we analyze it, or how do we prevent that particular thing from happening again? Mm-hmm. All of which has to, by definition, take place after the incident. So it's none of the current best practices or software norms are proactive. And I would say this is true for testing as well. Again, I'm not saying to not do any of these things, but testing relies on an engineer to think of the things that they could imagine going wrong, and then codifying a check and assertion around the validity of that outcome based on something that they know about the system, which means they have to know it about the system.
Yeah, and the system is the important part. So, if you talk about an engineer, he is focused on his space, his work. But a system is even more like just this tiny little, let's say, microservice. It contains a lot of more moving parts from technical sides, but also the organizational, the people, the processes, all that is needed to run and operate such a system. So, you need to test it at a large scale.
Yeah, and even so, I'll draw a distinction between testing and experimentation, but even still, that's still a reactive thing when somebody writes a test about something that they know that the system already does. I think that's the biggest thing. It's also the thing that attracts me to this space, because there are so many things that are intuitive about making something more reliable that turn out to be incorrect. So for example, you'd think, if I just spend more time being really precise about what the system does, then I'm going to make it more stable. The interesting outages are things that you couldn't anticipate. So sitting and putting brain power on it generally doesn't make a system safer. You think, if I put a bunch of guardrails on something, that'll keep it on the road. For systems under competitive pressure, guardrails tend to limit the behavior and experience of the people who operate the system. And that's what saves those systems from catastrophic outages or failures. So guardrails tend not to improve the reliability of a system over time, particularly for critical outages. there's a lot more that are kind of that flavor of like, oh, it just makes sense. Like, let me just document everything. Nope, doesn't help. Well, let me just measure, how quickly stuff is remediated, and then then I can shorten that time. Nope, doesn't work. So a lot of these things that intuitively feel correct are, again, provably wrong. Root cause analysis would be another one. Oh, let me just find the one thing that went wrong in this case. Nope, will not make your system more reliable. And so, instead, chaos engineering is part of a shift to an empirical practice and an experimentation practice. What basically the success of the healthcare system in the United States in Western culture is based on, to discover things that you didn't know about a complex system, and then use that to adjust behavior over a longer time frame. And those small shifts and small learnings lead organizations that embrace that to a very different place than the intuitive quick fixes that, again, most of the industry still resorts to.
Yeah. That's maybe a good opener for asking the question. I mean, if people want to get started with chaos engineering, if you talk to engineers, they're quite okay to know what they're getting out of it. But I mean, then there are also people, they are on higher levels and they don't really know what I'm getting out of it. So why should I break something? What is like the outcome?
Yeah. So I would say, first of all, you're not necessarily breaking something, right? It's chaos engineering is a lot more than just failure injection.
Correct.
Failure injection could be part of it. Doesn't have to be. And all of that is part of a broader thing called continuous verification. That that's the broader umbrella for reliability efforts like this, or a gold standard for reliability efforts. So I think you asked two questions. One is how to get started, and the other is how do you justify this to like upper management or like executive level decision makers who are further away from the engineering. Starting with the second question, like how do you justify this? The ROI is in the outcome. So, I'll give you an example. When we started evangelizing this, we started running conferences. The tech companies were engineer led, so they were quick to jump on board. And the first conference that we ran, had a lot of people from FANG and LinkedIn and big companies in Silicon Valley, and they kind of got it. But there were some banks there, some people from banks represented, and they would say things like, "Oh, well, you're talking about advertising and media, and these experiments sound dangerous, and if you go down, it's no big deal. But we have money on the line. Like, we can't do the same sort of experimentation that you're talking about." And so we would ask them, "Okay, so you don't have outages anymore?" And they say, "Well, no, of course we still have outages." Okay, well, if you still have outages, are you just going to keep doing the same thing and expecting a different result? Because we found a different way to work this system, and instead of running into that brick wall, maybe we can help you run around it or get a light to see that, the wall before you smack into it. And turns out that was a convincing argument. A lot of the banks jumped on it. The following year, we had a similar argument from healthcare companies, where they would say, "Hey, media, advertisement, money, that's one thing, but like we can't experiment with our systems because lives are on the line, human lives."
Yeah.
And again, same argument. Do you still have outages? Yeah. Okay. Well, in this case, there was a stronger connection because we could say, look, we built this practice on empirical principles of Western science, the quintessential example of which is the double-blind clinical study. Healthcare companies already do chaos experimentation. They just call it something else.
Yeah.
They do it with lives on the line in medical trials. That's part of their process. In fact, that's a requirement for broad approval of a drug through the FDA here in the United States. So, so this practice of empirical experimentation, it already saturates our culture. It's all around us. It's really just kind of like a semantic shift to see how that could be applied in one situation versus another. Mm-hmm. And again, this might be something that's that feels intuitive, that isn't actually real. I occasionally will run into people who push back on the term chaos engineering because they're like, oh, well, I understand how chaos engineering is important. Like, and it's not that we're engineering chaos, it's engineering around the chaos. But I could never sell it internally because there's no way my boss will go for something called chaos engineering. Mm-hmm. I've heard that a lot, and I've asked to be put in touch with those people, and I don't think they actually exist. I have yet to meet somebody who said, I won't do that because it's called chaos engineering. I've heard a lot of people who are anxious that they think it will be blocked because somebody won't do something, but I've never actually met the person who says, no, that word scares me. I'm not doing it because I'm afraid of the name.
I can share you a story, but not the name, of a company who told me, okay, yeah, we know it's important. We want to do it, but we already aligned internally, and there are some decision levels. We shouldn't call it chaos. We need to find another word, but we want to do it. And it really depends on who you are talking to. And people are still, as you told, afraid of the word of chaos, or that you will produce a lot of chaos, but it's the opposite. You're right.
Yeah. And again, like I've gotten that pushback, and from my point of view, I don't care what you call it. Like if the goal is to improve your availability,
stay on the principles, but
I still haven't met that person.
Okay.
I still think it's a group concept of like, oh, it makes me nervous because it's going to make somebody else nervous.
Yeah. I agree.
I don't think there's an actual person who can't have it explained to them in 3 seconds. No, actually, it's your system's already chaotic, right? Yes. Yeah. Okay. We're going to engineer around that. Oh, okay. So I still haven't met the actual, almost 10 years of this now. I haven't met the actual person who said, no, I don't like that name. I'm not doing it because of the name. So I think the more important thing is to tie it back to ROI, and a lot of chaos engineering programs are implemented in the wake of an outage because an executive mandate or comes down that, hey, what we're doing isn't good enough. Okay, how do you do something better? How do you do something proactive? Well, this is kind of the go-to proactive strategy. Yeah. So that's generally that's how chaos engineering kind of gets kicked off in a way that it gets executive adoption. In terms of I think your other question was like, how do you get started?
Correct.
I think tabletop exercises and game days are the best way to put your toe in the water. It can be a long path to a mature practice where you have continuously running experimentation that's smart enough to grab the attention of operators when something is unusual or going wrong, or has an aberrant or unwanted systemic effect. And starting is just okay, can we prod our system in as safe a way as we can and see that it does what we expect it to do?
Correct. And that's you mentioned it earlier, it's like this continuous verification where you start with your expectation and you would like to see that the system still works under many different conditions. And can you maybe provide some examples or practical examples from what verification-driven development can look like?
Sure. So usually continuous verification refers to like it's analogous to CI and CD.
Yeah.
So CI gave us all these advantages because the theory is bugs get limited the faster you can jam everybody's code together, right? Because the code is like the common understanding of stuff. So anybody writing in isolation is going to get less aligned. So CI just jams it together. Great. CD gets it in front of customers faster, right? Or end users. So again, it's shortening feedback loops. And CV is, okay, now that it's running, how do we shorten the feedback loop on systemic behaviors? And that could look like a lot of things. But for infrastructure, for example, imagine you have, I don't know, pick a piece of infrastructure.
RDS from AWS.
Okay. So what kinds of properties would you expect from that service?
Good process on write and reading.
Okay. And typically, what would you be putting in and fetching out?
Let's say customer data, customer attributes.
Okay. Just for people who aren't familiar, like what shape of the data?
Help me, please.
So JSON, SQL, large objects, like for, yeah.
Yeah, let's keep it simple, SQL.
Okay, great. So your bunch of SQL queries, and there's some relational thing there that you want to put in and put out. And imagine you have the best observability in the world hooked up to this, so most of the time that it's performing great. So even with the best observability in the world, it's still kind of a binary signal. Like, yes, it's working until it isn't, and then you're back in reactive land. Yeah. So to be proactive about it, what can we do? We can flood it with certain kinds of traffic, like many simultaneous connections. Since a SQL payload size going in probably isn't much of an issue, but coming out is. So you can vary the response size data sets that you get back out. You could have some SQL queries that are going to take longer than others, and then number of requests per second, right? So say we've just got those four variables that represent different properties or different variables of how the system can be interacted with. So what you want to figure out is where does this thing tip over? Like, where does it stop working the way your end users want it to work?
And it shouldn't be like now, yes or no. It needs to be like a little bit of a phase where you can see, okay, it's shifting in the bad direction and not like good or bad.
Yeah. So right. So we want to know what that boundary is before the end users hit it. So there's two ways that we can stress the system. One is with live traffic, and we can kind of like funnel it into hot points. The other is synthetic load. Doesn't really matter to me which of those you pick. Obviously, the live traffic is a little bit more authentic. If you can do traffic shaping to do that, but imagine you've got certain treatments now where you say, okay, I'm going to vary these four variables, and what I'm going to look for is, since it's an AWS service, rate limiting, or errors, or timeouts. And ideally, you're looking to find a statistically significant increase in one of those things before applications start failing. So, presumably your application has some sort of retry logic. If something times out, it'll just try again. Great. So you establish, here's my baseline rate of timeouts, timeouts, latency, or rate limiting, load shed. Yeah. And now I'm going to gradually increase the payload side coming back, right? That's one of the variables. And at some point, one of those observations is going to statistically increase, and you go, okay, now I'm approaching the limits of what this infrastructure can handle. So then you can taper that back down, then increase the number of concurrent connections, find the same point, note that, decrease that, now increase the requests per second, find the same point. And now you can kind of like triangulate or, draw a line around those points and say, okay, this is the map of where this piece of infrastructure fails. As long as I'm inside there, in terms of requests per second, SQL sophistication, payload size coming back, as long as I'm within those boundaries, I'm generally safe. Mm-hmm. I've empirically proved that. And once I approach one of those limits, I'm going to be in trouble. Okay, this is a level of detail and understanding, operational understanding, that almost nobody in the industry has about their infrastructure. So continuous verification establishes those boundaries. And then you can do all sorts of interesting things like that. You can set SLOs around those. You can set alerts around those so that if you approach them, you're headed in troubled water. That's proactive. And then the continuous part, you do this every day and track it over time, and you'll be able to detect changes in your infrastructure or in your complex system interactions through simple change point detections, so that when something else happens, AWS brings up another AZ, or you get a bunch of noisy neighbors on the underlying fabric at Amazon or whatever, you'll be able to notice that or be alerted to that. And again, that's just a signal, hey, operator, something's different in your infrastructure. You should probably pay attention to this. Again, that's a level of insight that almost nobody right now gets into their infrastructure.
Yes, I can agree. And the important part about it is you need to do it continuously, because your system is changing all the time. If you are getting new users, you're building new features, you are deploying a bug fix, whatever, your system is continuously in this moving situation.
Yeah, and it could be changing in ways that have nothing to do with what you or your team are doing. So, for example, one of my hobbies is collecting failure stories. I'll give you a failure story that highlights this. There was a large grocery retailer here in the United States. They did point-in-time testing for a Kafka cluster, and they determined 50% overhead in capacity. So, everything right according to industry norms. So they were using, this much capacity. They had a bunch of overhead, and they knew that their growth was going to be steady and, small acceleration. So they had, years before they would run into the ceiling on the capacity that they had. And so they did that before they set up the project, load testing, performance testing to establish that overhead. And then, some months later, the system just completely crashed hard. And they look back and they found out that a month prior to the crash, that ceiling had come way down because somebody in a completely different department saw the overhead and decided to change the network segmentation to use some of that network for something else.
Ouch. Okay.
Completely different department, completely different team. There's no way that they could have known about each other's plans. This is a very large, it's a Fortune 100 company. So lots of people, there's no way that they could have coordinated that in advance. So from the infrastructure team side, because they didn't have a continuous signal about their performance and the capabilities of their infrastructure, there's no way that they could have seen that coming. Kafka team is not going to sit there and go like, oh, well, let me ping the guys over networking every day to see if they came up with a new plan to change the segmentation.
Yeah.
If you're on the cloud, if you're on AWS could do something that they're not going to tell you about.
No.
That could change the performance of your underlying infrastructure, and that's a foundational component of your complex system. So it's got to be, you're missing a lot if you're not doing something that continuously updates your mental model about how these things are performing.
Yeah. And talking about this specific incident, and I really love the topic learning from incidents. So what was like the learning out of this incident?
What was it, or what should it have been?
Maybe both.
Yes, I believe the learning from that incident was, we need to put our network engineers in touch with the people who run infrastructure, out of those data centers. Is that the best learning? I don't think so. I think
until,
then, that's okay. Then they could run into the same problem with the team that runs electricity for the data center, and they wouldn't know that. So enumerating that list isn't going to be particularly helpful. I think the better learning would be, okay, we need to build a system that gives us this kind of continuous signal back in, so that if there is that change, we can go investigate and figure out, why did this happen? Oh, it's the network team. I mean, they were able to identify it after the outage. So it wasn't that the information was opaque or obscure. It just wasn't brought to their attention. And the way it should be brought to your attention is you should be able to empirically see a different signal or behavior in the complex system. So I believe that should be the takeaway. How do we notice when the system is behaving differently? And then we humans can go investigate what that difference is, and then decide what to do about it. Instead, they took a defense in depth approach, which was, we had an outage because of that. We'll put a process in place to make sure that outage never happens again. Again, intuitively makes sense. Not a great strategy for making your system more reliable.
Not only long term, absolutely. Talking about a little bit more about incidents in general. How should people react if there was an incident? I mean, you can learn a lot out of it, but still there are companies where an incident is still something bad and no one wants to talk about it. So let's continue. What is the best approach to handle an incident?
I don't know if we know what the best approach is yet. We know what bad approaches are. So the kind of controversial statement for companies that still do this is, if you're doing RCA, root cause analysis, the best case scenario, if you're doing RCA, is that you're wasting your time.
Yeah.
The worst case scenario is you're fundamentally undermining the things that actually make your system operate most of the time. And I'd say, I quickly illustrate that with an example. Say there's so many examples here to pull from, but say you have a system that goes down because somebody changed one line in a configuration file. This is kind of a common counterpoint to RCA. So you can get blame after the fact and say, this line, it was written by John. It's John's fault. That's the root cause. The root cause is John. Just to show how absurd this is, you can say like, okay, well, what was happening in John's life at that point? He was going through a messy divorce. So it's actually John's, the divorce lawyer's fault, right? Like there's really no logical end to that. It's arbitrary where we tell the story. But here's the worst part from in terms of value to the company, the organization that's doing this. So what if you found out that it's John's fault? Do you think you're going to avoid an incident by shaming John or slapping him on the wrist or having everybody stand in a circle and point at John and say, don't do that again? No, you're not. But that's the point of RCA, is to drill down and find the smallest thing smallest person in the hierarchy to blame for what caused an incident.
Mm-hmm.
Flip it around. John's boss. You could say, oh, well, it's John's boss's fault that they didn't hire better, say. Or you could go to the director and say, oh, well, it's the director's fault for not setting better contacts with the manager. Oh, it's the VP's fault for not putting more funds into resilience efforts or systems to make it more reliable. SVP, again, fund allocation. CTO, well, they didn't align the organization, the technical organization, around the things that are important to them. CEO, they didn't express to the rest of the company why it's so important for the system to not go down in terms of business continuity.
Mm-hmm.
Now, those are just completely different stories, any one of which you could choose. Again, RCA points to the first one, which does nothing to prevent an outage. If you go to the CEO can move mountains.
Yeah.
So if you actually want to prevent additional outages or deter them, you want to work on the CEO, which again, RCA is going in the wrong direction.
Mm-hmm.
It would be something else that goes up and says, how can we readjust the hierarchy and the entire system to have a better outcome? And the CEO doesn't care about one line in a configuration file, and they shouldn't. So at best, that exercise of finding the line in the configuration file and concluding that was a root cause was a waste of time. At worst, you shamed somebody, and that had a negative impact on company morale and made people more prone to hiding things instead of sharing them, and all sorts of chain reactions that are bad for a company's culture. That's the worst case scenario. But again, the best you could possibly have from that is that you wasted your time by pointing out something that's not going to prevent any future incidents.
Yeah, and there's then zero learning in it because what you're getting out of it, you're nothing. And
so a better way to go about incidents is just as an example, people are, well, I do RCA and I feel like we learned stuff from it. So like, what else is there? So one other example, counterexample, and there's an infinite number of other ways you could do it, but one counterexample would be have an investigator go around and interview people impacted by the outage. And then they're just there to capture different narratives and notice the difference between the narratives. Then bring everybody who's impacted back into a room and facilitate a discussion so that person A will say, well, I did these things because they make sense. And, but person B, you did these things because they made sense to you. But look at how your understanding of the system was different from theirs. Oh, yeah, okay. I didn't know that system had a fallback. I didn't know that they had a requirement that their network segmentation, would be adjusted if there was excess capacity. Right. Okay. Now you learned something about how the organization operates that you wouldn't have known before. And then, person C chimes in, well, actually, that's not how it works. Like there's actually this other element that you didn't see. Okay. Now everybody is updating their mental models together constructively to form a better overall understanding of how a complex system works. That's going to get them further in terms of optimizing the system for what the system has to be optimized for and avoiding bad outcomes than anything that happens in the RCA in terms of, config files aren't read this way or whatever. So that's an example of a different way to do it. But again, the most valuable outcome would be going up the organizational level and saying like, okay, well, why do these people have different understandings of the system?
Yeah.
Why are we spending our time moving the technology in this direction if customers actually want it to be optimized for these properties instead, uptime instead of features, or uptime instead of cost to utilization performance or whatever. So, again, there's near infinite number of ways that you could handle a post-incident review or analysis. RCA is to be avoided.
Yeah. So don't care about the root cause, more improve how your socio-technical system really works and how everyone can be part of it and to improve your system continuously.
Yep.
Let's take a look in the future. Let's take a look let's say, in the next 2 to 3 years. Do you see any big trends coming up for in the space of resilience and reliability engineering?
Yeah, so I do see continuous verification is the adoption is increasing, not always under that name, but systems for which high availability is critical. Healthcare systems in particular, but also some financial ones are by necessity exploring this route of like, okay, how do we understand our infrastructure before something bad happens? How do we understand what the boundaries are before we end up driving over the edge of the cliff? So that's good. I think the thing that is consuming most people's attention span right now is how does AI help or hinder this effort?
Yeah.
And that's TBD, right? Like that could branch in a couple different directions. I'm seeing good applications of LLMs in particular, summarizing events and information so that it's easier for people. We're all too busy. We all have limited attention.
Yes.
Easier for people across an organization to quickly consume, like, oh, okay, that's generally what happened to that thing over there. And again, helps me update my mental model of the whole system. There are areas of AI that are problem solvers. LLMs are not that. So on the bad side, I would say we're going to see a lot of funding continue to go into startups that say, we can automatically do RCA. We can automatically find incidents before they happen. LLMs aren't that technology. So the AI that is currently sweeping over the planet doesn't help with that. And then at the end of the day, reliability and the ability to and resilience, the property of something that can react to a new circumstance and steer it towards a more desirable outcome. That is a property of improvisation, which right now only humans can do. AI, again, LLMs don't do that. They can, hallucinate suggestions, but they are very poor about having the business context necessary to correctly improvise. And so that's what we need humans for. So again, you're going to see a lot of money poured into AI that automatically resolves incidents. And LLMs are a very poor fit for that. But there might be a space for LLMs to very quickly ingest or digest a data set that's too big for a human to digest, and give them a signal about the current state of the system that helps the human improvise better.
Yeah, absolutely. More like a summary about all the signals, all the noise out there, to get a nice overview about what's going on in my system.
Yeah. So lots of opportunity, I think, where AI could help. But as with probably most of the AI implementations that we're seeing now, just like numerically the number of startups that are coming up, most of those are probably a bad idea in the space of resilience.
Don't let the VCs know that. Anyhow,
I'm happy to talk to VCs about their technical investments. That is, I do consult with VCs on this. Yes, I have not steered any VCs towards the companies that are making those kinds of claims.
Yeah. All right. So last question. So first of all, I really enjoyed our conversation. I learned again a lot. And thank you very much for being my guest. Last question. So when people want to reach out to you, when people want to talk to you, what is the best way to get in contact with you?
Oh, I'm on LinkedIn. That's a pretty easy way to find me. Blue Sky is generally where I hang out in public now. I try to stay away from X, and I don't think I'm on any of the other social things. So that would be the way to do it.
Cool. Then again, thanks for joining me, and looking forward to see you in real life again.
Right on. Thanks, Benjamin. And I am super glad that you continued with that chaos project and continue to advance the field. Thank you very much.